Welcome back. This is Lord's Made. Lester Dress McGlad in it. We talk about work and power for physical science. So work is a transfer of energy. And so it's a lot of different ways you can calculate this because anytime you have transfer of energy, that energy can go into different forms. You could be changing the potential energy or the kinetic energy of the object you're talking about. So work can be calculated a variety of ways. We're going to talk about that here in a few seconds. Comparing work to power, power is just how fast you do it, how fast you're able to transfer the energy. So if you know how much work you did and how long it took, if you just take the work divided by the time, that tells you the power. We measure power in watts. So anytime you buy an electronic device, it'll have some capital W next to some number on the device saying, here's the wattage of it. And as an example, you buy a light bulb, it might say 60 W. That means that that light bulb uses 60 watts or 60 joules of energy every single second. Back to work. So work can be calculated a variety of ways. One way when you think about work is a mechanical thing where like you're applying some force in newtons to make something move a certain distance. So work can be thought of as a force times a distance. So I apply a certain force for a certain distance, I'm doing work. So that's one way to think about what work is. Work can also be just energy to be transferred and potential energy or kinetic energy to the thing. So if you lift an object up, you're changing its potential energy. The work would be the change in that. So you lift a block up, you did a work on it. Or change kinetic energy. If you throw a baseball, the baseball, you gave it some energy, you change its kinetic energy, that is work. So some sample questions about work. How much work does it take to lift a block of a certain mass, 5 kilograms, to a height of 2 meters above Earth? So what kind of work are we doing here? We're changing the potential energy of it because we're lifting the block up. So in this case, work is a change in energy that is specifically potential energy. So the work will be equal to a change in potential energy. So, and we calculate change of potential energy by a mass times the gravity times the height. So the work here will equal the mass times gravity the height. So 5 kilograms times 9.8, which again is gravity, times 2, that is the work done. So the change of potential energy was 98, which is also the work we did. You might have a question where it gives you the force and how long you're applying the force for. In that case, we just take the force times the distance. So if we apply a force of 100 newtons for a distance of 10 meters, the work would be just 100 times 10 or 1,000 joules of work. This would be a kinetic energy one. How much work is done by your car, the engine, to make your car accelerate from rest to 20 meters per second. So this time we're not changing the potential energy of the car, we're changing the kinetic energy of the car. So the work is equal to that change in kinetic energy. So we're going to use the kinetic energy equation. So that's going to be 1/2 times the mass, which is 1,000, times 20 squared. That's the amount of work that's been done by the car engine to make your car get up to speed. Now let's connect this to power. And power is just how fast you're doing the work. So it's going to be how much work you did divided by the time it took you to do. Just for your random knowledge, 1 horsepower is about 746 joules a second. So if you can do 746 joules of work in 1 second, that's 1 horsepower. So a typical person can't do that. If you compare this to your body, our body is roughly 100 joules of energy per second when we're at rest. We basically run on 2 light bulbs worth of energy. And so in order for you to be outputting about 756 joules, or that's going to be about 7 to 8 times as much energy as you normally are expending. So that's pretty intense. So let's go back to our last example with the car. Let's just change it so that instead of asking for the work done, let's find the power done by the car engine. So it's almost the same question as last time. Last time we asked for how much work was done by the car. This time we're asking for the power output. So same size car, same final speed. The only difference is I give a time. And so now we can find the power. Again, same things before. We're just changing the kinetic energy. We still get the same 200,000 joules of energy from the previous question we solved. But since it wants power, all we can do is take that work that was done and divide it by the time. So we did 200,000 joules of energy worth of work. Took us 40 seconds. That's 5,000 watts. And that's not a whole lot. If you divide that by 750, it's roughly 6.7 horsepower. Your car probably has more than this. Here's another sample. How much power would be required by a person's legs to accelerate your body of 50 kilograms to a speed of 10 meters per second in 5 seconds? Again, we're going to find out how much work was done and then divide by the time. So we're just taking into account the time at the very end. So what kind of change in energy do we have here? We have a change in kinetic energy because we are changing our speed. So power is going to equal to the work over the time, and our work is actually changing kinetic energy, which is 1/2 mv squared. So we can solve for the amount of work that's being done by taking 1/2 times the mass times 10 squared, then dividing by the time. And in this case, that's about 500 watts. So about 2/3 of a horsepower. So again, big idea here. Work is any type of transfer of energy. It can be calculated a variety of ways. It could be a change of potential energy, a change of kinetic energy, or it could just be a force over a distance. Those are all examples of ways that you can change the amount of transfer energy to something else. And so when you're doing questions, keep an eye on which one you're changing. Am I changing potential, kinetic, or do I already have a force and a distance? And then solve appropriately. And if I ask for power, just do the same thing you just did, solve for the change in work, then just divide by time at the end. God's peace.